Howdy folks, here's what we're going to do today. In this video, or this series of videos, what we're going to do is we are going to learn how to identify what are called the relative extrema of a function and the intervals of increase and decrease of a function. Now, you were able to do this probably in previous math classes so long as you were given a graph. So you could look at a graph that maybe looked like this, and you, as long as you were told what the x values were at these peaks and at these troughs, as long as you were told, so let's say that this is 4 and this is 6 and this is 9 and this is 14, you could say that this function, let's say that this function is f of x. You could say that there is what is called a relative maximum, and I'll explain this later. See, it's a high point. A relative maximum is a high point on a graph. You could say there's a relative maximum at 4. This is a relative maximum. This is a relative minimum. It's a low point. It doesn't have to be the lowest point. It's a relative or local minimum. Relative minimum. This is a relative maximum. And this is a relative minimum. Okay? Then, because along this interval, the graph has a positive slope, if you remember from my last video, positive slope means increasing, negative slope means decreasing. So because this graph has a positive slope right here, this is an interval of increase. And because the graph has a negative slope here, that is an interval of decrease. And then here's an interval of increase, an interval of decrease, and an interval of increase. Okay? So that's what we're going to do here, but we're going to do it analytically. We are going to use functions, and without graphs at all, just using functions and derivatives, we're going to be able to identify the intervals of increase and decrease and the relative maximums and the relative minimums of any function. Okay? And the way that I'm going to teach you how to use a tool that will help you be able to identify these things. And the tool that I'm going to teach you how to use is called a sign chart. And you may already know what a sign chart is, and you may already know how to create a sign chart. And if you do, then you're already ahead of the game. You can move forward to the videos where we actually use the sign chart. Okay? But if you do not know how to make a sign chart, I'm going to show you how to make a sign chart in the next video. But in this video, I'm going to teach you a skill on the TI-84 calculator, which will help you to be able to make a sign chart. Okay? So we're going to start with, in this video, in just a minute we're going to switch over to my computer. What we're going to do here is I'm going to show you how to use a TI-84 calculator to identify the zeros of any function using the graph feature. Okay? So let's say that we had some function. Let's say that we have f of x is equal to x squared minus 3x, let's say minus 12. Okay? So this function crosses over the x-axis in two places, and we don't know what those two places are. Now, we could use the quadratic formula to find the two zeros of this function, but you can also use the TI-84 to find the zeros as well. You probably have already learned how to use the quadratic formula to find the zeros of this function. And if you have never used the TI-84 to find the zeros of a function, this will be a good opportunity for you to learn. So why don't we go ahead and switch over the computer, and I'll show you how to find the zeros of this function on the TI-84. Okay, so here's what we're going to do. We are going to use the TI-84 right here, and here is the 6 steps that we need to be able to identify the zeros of a function. So what we're going to do here is we're going to turn on our calculator, and we're going to clear here. And I'm going to go to, let's clear this. Let's act as if Yeah, here we go. All right, so you first turn on the calculator. Let's say you see this screen. The first thing you're going to do is you need to enter the function in y equals. So right here, this button right here is the y equals button. So you're going to click on that. And as you can see, you can actually enter multiple functions. And what we're going to do is we're going to enter our function, the one that we saw up on the board, which was x squared. So we're going to hit the x button, then we'll hit the squared button here. Then it's minus 3x minus 12. Now, once we've entered our function, next thing we're going to do is we're going to press the graph button. The graph button is over here on the right-hand side near the top. Almost all the way at the top. We're going to hit the graph button, and now the graphing calculator is going to graph the function. And what you can see here is right here, the graph is crossing the x-axis, and over here, the graph is crossing the x-axis, and those are the two locations of the zeros. And so we're going to identify the value, the x value of this 0 and the x value of this 0 over here. So the next thing we're going to do is we're going to press the second button, which is this blue button right here. Then we're going to press the trace button, and that's this button right here. Then we're going to press 2. We're going to select option 2, which is this button down here. So if I press second and then the trace button, it gives me what's called the calculate menu. And then you can see option 2 is 0. That means that we would be finding the zeros of a function. So if I press 2, watch what it then asks me. It says left bound. And so what it's asking me to do is it's asking me to set boundaries on where it's going to look for the zeros. And if this is the 0, I want to go to the left side, any x value that is on the left side of this 0. Now this 0 looks like it's at about maybe negative 2.5. So I need a value that's smaller than negative 2.5. See, when it says left bound, you're entering an x value that is smaller than the 0. So I need a number that's smaller than negative 2.5. So I'm going to enter maybe negative 4. So I'm going to key in negative 4, and then I'm going to press enter. And so you can see it puts this little arrow. This is telling you the boundaries where it's looking for the 0. So this is as far left as it's going to look. Then it says right bound. And so now I need an x value that is larger than the 0. So something larger than the 0. If this looks like it's about negative 2.5, so maybe I'll put in negative 1. Negative 1 is larger than negative 2.5. So I'll key in negative 1, and then I'll press enter. And now it says guess. Now the reason it gives you guess is in case you have more than one 0 on that interval, more than one place where the graph crosses the x-axis, it's just asking you to guess the value or give it some direction on where it should be looking. Now because there's only one 0 on the interval we have indicated, all we have to do, we don't have to enter a number, we can just press enter and it'll look in there. And as you can see, it gave us x equals negative 2.274917. That is one of our zeros. And then we would write that down somewhere. Okay. Now we've got a second 0 to look for, and that's right over here. And so we are going to, step 7 actually is to, let me see if I can write this in. Let's see, step 7 is to repeat. Repeat. I'm not very good with this, I'm using a mouse. Repeat steps 3 through 6. Okay, so we're going to repeat steps 3 through 6. And if we repeat steps 3 through 6, we can find the 0 over here. So we're going to hit second, then trace, and then option 2, and then left bound. Now we're going over to this 0 over here. So it looks like it's at about, let's see, 1, 2, 3, 4, it's about 5. So I'm going to put in 4 as left of 5 and press enter. Then right bound, 6 is on the right side of this 0, so I'll hit 6, enter. And then guess, I'm just going to hit enter. And now you can see there's a 0 at x equals 5.2749172. Okay? Let's do one more example, just so you can get an idea on how to do this procedure. So we've already identified those two zeros, and so we're going to change the function. I'm going to hit y equals, and I'm going to hit clear, and I'm going to put a new function in. Let's just put in something kind of simple. I'm going to put in sine of x, and I'm going to put sine of x minus, let's say, 0.5. And then I'll hit graph, and you can see here. And let's identify maybe this one right here. You can see it's crossing over. In fact, we can get a better look at this if we hit window and then change our viewing window. Actually, let's hit zoom. And I'm going to choose Z box, which is zoom box. And what that'll allow me to do is to put a kind of put a box around the area I want to view. So I'm going to hit enter, and then I'm going to scroll up here. I'm going to scroll over, and I'm only going to see I'm only going to see 3 zeros when I stop right here. And we can see it crosses there, and it crosses there, and it crosses right here. So let's identify this 0 and this 0 and this 0. This time I'm going to do it a little bit differently. Instead of keying in values, I'm actually going to use the arrow buttons. So I've got my graph. Now I'm going to go to press second, trace, and 2. So I hit second and then trace, and that gives me the calculate menu. Option 2 is 0, so I'll hit 2. And now watch this. This is the 0 I want right here. So left bound means I want to be on the left side of this. So I'm going to hit the left arrow, and do you see the cursor moving? I'm going to put the cursor near the x-intercept, so right there. And now I'm going to go to the left. I'm going to hit the left arrow, and that's going to take me over here. And then I'm just going to press enter. And that's set the left bound for where it's going to look for the 0. Then it says right bound. So I'm going to hit the right arrow, and I'm going to go to the right side of the 0 and press enter again. And now it's going to look between these two arrows right here, and it's going to find this 0. It says guess, so I'm just going to press enter. It's telling me there's a 0 here at 0.52359878. Okay. Now I'm going to look for this one right here. So I'm going to start over. I'm going to hit second trace 2, second trace option 2, which is find the 0. And now I want to move the cursor with the right arrow over to this 0. But it says left bound, so I got to move left. So I got to hit the left arrow button. And now I'm to the left of that 0. Press enter. And it says right bound. So I'm going to hit the right arrow, and I'm going to go back to the 0. And then I'm going to move right a little bit. Press enter. And now it's around, these arrows are around. They're one x value is smaller, one x value is larger than the 0. I just press enter when it says guess, and it says there's a 0 at x equals 2.6179939. And now we've only got one left to find over here. And so I'm going to hit second, trace, option 2. And then it says left bound. I'm going to arrow all the way over to that other 0 right here. And I'm going to hit the left arrow until I am on the left side of that 0. Press enter. Then it says right bound, so I'm going to hit the right arrow until I'm on the right side of that 0, and then press enter. Now it says guess, and I can just press enter, and it tells me there is a 0 at 6.8067841. So we just identified all 3 of those zeros. So that's it. That's how you identify a 0 using the TI-84 calculator. If you want to go back to the regular screen, you can press zoom 6, and then that'll take you back to the normal screen. And now we're going to go back to the whiteboard, and we're going to do a couple of examples on how to identify the zeros of functions. So let's go ahead and start with this first one. And the first thing we're going to do is we're going to enter the function in y equals. So we're going to turn on the calculator. Hopefully you've practiced this a couple times. So we're going to hit turn on our calculator, and we're going to press y equals. Then we're going to key in this function. I'm going to press x, and then I've got an exponent button. Hit the exponent button to the 3rd power. Then I'm going to arrow over minus x squared minus 12x plus 11. All right, so I entered the function in y equals. Now I'm going to press the graph button, which is right over here. Now, if you press the graph button and it doesn't look the way that you want it to look, if you want it to go back to the normal screen, you can press zoom and then 6, and that's called zoom standard, and it'll get you back to the 20 by 20 viewing window. Okay, so once we have that, I can see that the graph crosses over the x-axis, right, in 1, 2, 3 different places. So we are going to be identifying 3 zeros. So now we're going to press second, then trace, then 2. So second trace, that gives us the calculate menu. Option 2 says 0. That means we're going to find the zeros. Then it says left bound. We want to choose an x value less than the 0. Well, let's try and find that one first. And that one looks like it's somewhere near -1, -2, -3. Maybe it's between -3 and -4. Left of there is definitely -5. So I'm going to key in -5, then press enter. And you can see that it puts that arrow right up there. Then it says right bound. So then to the right of this, let's choose maybe -2 possibly. So key in -2, enter. Then it says guess. And because there's only one 0 between those two arrows, we don't have to guess. We just have to press enter. And when we press enter, it says 0 is equal to -3.431375. You see that? So that's one of the zeros. So one of our zeros is x equals -3.431375. That's one of our zeros. Now let's try the second 0 because there's 3 zeros altogether. So now step 7 here is if you have more, you're going to repeat steps 3 through 6. 3 through 6. Here's what I mean. Once you find that 0, your calculator is no longer in 0 mode. You have to go back through the second trace 2 and then identify the quality or the location of the second 0. So we're going to go second trace option 2. Left bound, we're looking for that 0. Looks like 0 is to the left of that 0. So we're going to hit 0, enter. And then right bound, it looks to me like maybe 2 is on the right side. So I'll hit 2, enter, guess. I'm just going to hit enter. It says there's a 0 at 0.91048267. So I'm going to say that there is an x at 0.91048.267. There we go. That's the second 0. Now let's find the third 0 here. I'm going to go second calc, option 2, 0. Now this one all the way over here looks like it's at about 2, maybe between 3 and 4. Let's try that. Left bound 3, right bound 4, enter. Guess, I'll just press enter. It says it's at 3.5208926. So I have an x value at 3.52085208926. And there we go. Those are the 3 zeros of that function. TI-84 made it possible. Again, you can do this with a TI-83. It'll do the same thing. And there are lots of other graphing calculators out there that can do this as well. But we're working with the TI-84 and the TI-83. Okay? All right. Let's identify the zeros of this next function right here. Y equals e to the cosine of x minus 1. All right. Well, how am I going to enter that function into the calculator? Again, I'm going to hit y equals. Then I'm going to hit clear for y1. And I'm going to key in e. E is above the ln button down here. So I'm going to hit second and then ln, and that gives me e to the power of. Then I'm going to key in cosine, which is right here. Now you're going to need to make sure your calculator is in radian mode, because in calculus we work in radian mode. So if your calculator is in degree mode, it's going to look very different than what you're going to see here. Cosine of x, close. Then I'm going to come out of the exponent and it says minus 1. So minus 1. And then I'm going to hit graph. And this is what I get. There we go. Kind of a funky looking. And you know, let's just find a couple of them here. Let's only find the ones on the positive side. There's 1, 2, 3 zeros. Let's find all 3 of those. So we're going to hit second trace 2, second trace 2. And then this first one right here looks like it's kind of between 1 and 2. So let's try that. Left bound 1, enter. Right bound 2, enter. Guess, just press enter. And it says there's a 0 at 1.5707, 963. That's actually pi over 2 is what it is. Okay. And so we're going to say x is equal to 1.5707, 963. There we go. And now the next one, we're going to hit second calc 0, option, which is option 2, right? And it says left bound. The next one looks like it's between, let's see here, 2, 3, 4, maybe 5 and 6. left bound 5, right bound 6. Press enter. Maybe I'm wrong. Yeah, okay, look at this. See, error, no sign change. This means that it's actually not between 5 and 6, so I'm actually going to choose between 5 and 7 this time, okay? So I'm going to go back, I'm going to quit, hit graph, I'm going to hit second, trace 2, left bound 5, right bound 7. Guess, enter. Oh, it says no sign change, it must be less than 5. So I'm going to hit 1, graph, second, calc, option 2. This time, let's see here, that must be 2, 3, maybe between 4 and 6. Left bound 4, right bound 6, press enter. There it is. It's at 4.712389. There we go. I was guessing or trying it out too high. 4.712389. Now, one more. We got this one way over here. To me, it looks like it's maybe between 6 and 8. So I'll hit second, calc 2, left bound 6, right bound 8, enter, and I get x equals 7.8539. X equals 7.8539816. There we go. And so those are I only chose those 3 zeros, so there they are. Let's try this next one here. I think it only has 1 0. So let's try this logarithm. The natural log of x minus 2 minus 1. So we're going to go into y equals. We're going to clear out y1. And I'm going to key in. I'm going to hit the natural log button. Then I'm going to key in x minus 2. Then I'm going to close the parenthesis. Then I'm going to hit minus 1. Then I'm going to hit graph. Whoops, I hit clear by accident. That's not good. Natural log x minus 2 minus 1. Then I'm going to hit graph. All right. Yeah, it looks like it only crosses over the x-axis in one place, right there. So I'm going to hit second, trace, option 2. Now watch this. This time what I'm going to do is I'm going to use instead of entering a number, I'm going to hit the arrow button. Look at this. Where's the cursor? I'm looking for the cursor. There it is. I'm going to make sure the cursor is to the left of the 0 and just press enter. Then I'm going to move the cursor over to the right, so I'm hitting the right arrow. So now the cursor is over on the right side of the 0, and I'll press enter again. Then if it says guess, I'm just going to hit enter, and it tells me that the 0 is at 4.7182818. So x equals 4.7182818. There we go. I'm seeing an E in there. Look at that. 1828 at 1828 shows up in E. So there's only 1 0 in that one. Now let's move on to number 5 there. Go ahead and enter this one into your calculator. Hit y equals. Then clear out the natural log function. Now key this one in. 5 times e. You have to hit 5. Then you have to press second and ln, and that'll give you e to the power of. Then you got to key in, don't put the minus button. You have to hit the negative button that's under the 3. So hit negative, then an x, then hit the squared button. Then you got to come out of the exponent and put minus 1. So this is what it should look like right there. Then hit the graph button. So hit graph, and it looks to me like there are 2 zeros. Looks like it's crossing over the x-axis over here and over here. So let's see if we can find those zeros. So we'll hit second trace 2. And it looks like one of them is kind of between -2 and 0. So left bound -2, right bound 0. Guess, just press enter. And one of them is at x equals, oh, yeah, there it is. It took a little while to get it, but -1.268636. 68636. And I'm betting that the other one, it looks very symmetrical there to the y-axis. I wonder if the other 0 is at the positive version of this, but I'm not going to make any assumptions. Let's go ahead and hit second, trace, then option 2, left bound. The next one looks like it's between 0 and 2. So left bound is 0, right bound is 2. Press enter, and I get, yep, sure enough, 1.2686362. X equals 1.2686362. Yeah, the reason I kind of knew that is because if you look at this, this is actually a Gaussian function, which is basically an e to the negative x squared function, and e to the negative x squared functions, they look like this. They're very popular in statistics. This is one of the places where calculus and statistics cross paths. Why it's so important for people who are going into statistical fields, they really should know calculus. Okay? All right, let's do this last one here. All right, put in 2x. Now I got to clear out this one, and then under y1 I'm going to put in 2x sine of x. I don't know if you notice it, but this is actually a derivative. This is actually a product rule derivative. And then we'll hit plus x squared times cosine of x. Make sure you're in radian mode. Then we're going to hit the graph button. And it looks kind of crazy. So you watch this thing draw. Yeah, it looks sort of weird there, right? Okay, hopefully yours looks kind of like that. And now let's just look for these zeros right here. Let's look for the 3 in the middle. Okay, or maybe we'll start here and we'll go over here. Let's do a couple of these. Let's start with that one. Where does it look like that 0 is? Looks to me like that 0 is at 0. But I'm going to show you something crazy about this. Let's go ahead and do our second trace 2. Second trace option 2. And it looks to me like that 0 is somewhere between -1 and +1. So we're going to put in left bound -1, right bound +1. When it says guess, we're just going to press enter and watch your calculator struggle. Now, if you have one of the newer TI-84s, you're going to be just fine. TI-84 silver, you're probably going to be fine. The color, TI-84 color. But I got an old school TI-84 plus. Look what the TI-84 plus says. It says error, no sign change, and then I can press 1 to quit. Now, it looks to me like there really is a 0 there at 0. But here's the thing, is that sometimes these calculators won't find a 0 unless there is a change in sign. The graph has to go from negative to positive or from positive to negative to get a sign change. And because I think that there really is a 0 there, watch what I'm going to do. I'm not going to do second trace. I'm just going to hit trace. And I'm going to trace x equals 0, press enter, and look what I get. X equals 0, y equals 0. So sure enough, there is a 0 at 0, but I had to use a different method to find it. So I know that one of the zeros of this function is at x equals 0. So now I'm going to find maybe just a couple more. The next one over to the right looks like it's between 2 and 3. So I'm going to hit second calc, choose option 2, left bound 2, right bound 3, then I'm going to press enter, and sure enough, 2.2889, x equals 2.2889, 297. And then the next one over from there looks like it's maybe between 4 and 6. So I'll hit second trace, option 2, left bound 4, right bound 6, press enter, and I get 5.086981. X equals 5.086981. All right. Hopefully this was plenty of practice for you to be able to understand how you can use your TI-84 graphing calculator to find the zeros of any function. It's a really great technique. And you're going to need it in the next several videos that I have in the next several days that we have in this class. It's one of the required skills for taking the AP Calculus exam. You don't even want to sit down for the AP Calculus exam unless you know how to do this, okay? So I hope this helped. Have a great day.